So the existing product is a salt, potassium chloride. Pretty much 40% or 48% of that product is chloride. So whenever you're applying potassium chloride to your crops, a large proportion of that is chloride, which is non-ideal. Several crops out there are actually sensitive to chloride, so it is very suboptimal to use that product on those crops, and some of them you have to rely on very expensive alternative products instead. Given it is a salt, it solubilizes very quickly. So in places where it rains very much, the losses which are incurred through leaching, i.e. it rains, that product, it solubilizes, the water of the rain carries away a big part of the product that you applied. So you have significant efficiency losses through that. Another issue is that given the salinity of the product, it is also not ideal for the microbiome of the soil. Our product is produced from a silicate rock, i.e. it has absolutely no salinity. The advantages of our product comprise it has controlled release of the nutrients. We suffer no losses through leaching, given the crystalline structure of our product. We have absolutely no chloride, and we are microbiota friendly. And this is these main four characteristics together make our fertilizer be a very high efficiency and very good for crops. And we have shown that through our partners. Embrapa and Wender is the Brazilian agricultural company in Brazil, is very well known and respected. And we also work with the IFDC here in the United States. So these are our two main agriculture partners. But we're also working together with the industry. For example, SLC Agrícola in Brazil, FMT, which is Fundação Mato Grosso in Brazil as well. We're all doing field trials as well as greenhouse tests with them. And now we're starting to explore another angle as well, which is to combine our product with bacteria, which goes very well into the trend which agriculture is going to right now, which is to use bacteria together with fertilizers to enhance crop yields. So there are a few characteristics that make our fertilizer perform so well and increase crop yields compared to the existing solution. So a very big point is that the potassium which is contained in our product is released over time, and we call that a controlled nutrient release. That is to show you the importance of that. Essentially, as opposed to solubilizing, providing the nutrients of the crops all at once, meaning that the plant or the roots have to eat their meal, you can imagine it, their entire meal of the month in one day, we provide that nutrient over the course of the entire growth period. And that means that a plant doesn't have to absorb everything at once, but can uptake that nutrient whenever it needs it. There is a very big difference vis-a-vis the solution that exists out there. Another big problem that fertilizers currently have is that they solubilize very quickly. And when it rains and the product solubilizes, a big part of the nutrient is actually carried away by water, and we call that leaching. So it's either carried away by water or it just goes into the soil to a point where the roots cannot uptake that nutrient anymore, and essentially it's lost. So the farmers are a big portion of what the farmer is actually applying to the crops is effectively lost. Our product, given it is not a salt and it does not solubilize immediately, given the crystalline structure of it, we do not lose anything or any of the potassium which is contained in our product through leaching. That is another characteristic. Another very important one is the salinity of our product. The existing solution has a fairly high salinity index, which means that you're effectively adding a salt every time you apply that product to the soil or to the crops. There are crops which are more or less sensitive to that. When it comes to berries, citrus, almonds, and other types of crops, these are extremely sensitive to that, meaning that you cannot even apply that product and you have to rely on some very expensive alternative products. Our product, on the other hand, given it comes from a silicate rock, it doesn't have any salinity at all. That means that you have no limitation to apply our product on any soil type or crop type as well. And lastly, also derived from Salinity, the existing product is not a good host for bacteria. So it's very difficult for you to combine both, which would actually be ideal if it was possible. Given our product has no salinity, it is microbiota friendly as well. So we're at the moment studying and developing products where we combine our fertilizer, hydropotash, together with bacteria.